All right, so how do we name the chemical formula? If we are given the full name here, we can see we've got magnesium fluoride. How do we now turn this into the formula? So we're sort of going in the reverse direction here that to what we did in the previous examples. So we are going to need this, but we're going to need to use, if you will allow me to, this guy right here, because we need to look at the ions. But before we do that, let's just figure out what we're dealing with here in terms of our symbols. So we go back to our periodic table and we look up where magnesium is. And sure enough, if you look hard enough, you can see magnesium is there, and it has a symbol Mg, capital M, lowercase g, and fluoride. Now, if you look specifically for fluoride, you're never going to find it. What you got to remember here is we changed the ending here. The IDE actually isn't IDE, it should be INE, so it's fluorine. Now, if you go and find fluorine, you'll find it up there. There it is. So, the first step, if we want to write this as a molecular formula, is we need to write those symbols down. So let's do that, shall we? M, capital M, lowercase g, and because we're starting the second element, we got to start with another capital, which is F. That is our start. Now, we don't end there because we have to look up where this all fits. And this is where we need to look at this guy here, our chart. So I'm going to put this on top like this. Just the same as our periodic table that we had before, but we've got just specific ion charges. This is what we want to look at. And again, these ion charges come from the electron arrangement. So Mg has an ionic charge of +2. Essentially, what that means is that it is willing to give up 2 electrons and be left with a shortage of electrons, 2 to be specific, and as a result has a charge of +2 when it does. Fluorine, if we take a look over here, fluorine has a charge or ionic charge of -1, meaning that it is going to be able to take up 1 electron before it has a full shell, and at that point it's just going to stop. So that's the reason why it has a charge of -1. It has an abundance or an extra electron when it does take up that electron. All right, thing is that these don't necessarily match up. We've got, and let me just write this out a little bit here just to give you a bit of a background. We've got a situation where we have a magnesium that has an ionic charge of +2, and we also have a fluorine that has an ionic charge of -1. The problem is we got to have these charges, have these balanced so that whatever positives we have on one side, we have the same number of negatives on the other side. Because again, this is a situation where we want to have our charges balanced. Let me just sort of zoom back out here for myself here. All right, so what we're going to do is we've got 2 electrons to give away here and atoms that will only take up 1. We often think of this as being, well, look, if we have 2 electrons to give away, this can actually help out not just 1 fluorine, but 2 fluorine. And as a result, we indicate that, so we could say literally, we could have 2 fluorines helped out by that. And we write that down here in our formula as a 2. Subscript 2. So the real complete answer for this is Mg F subscript 2, or the small 2 there. All right, that's how you do it. That's an ionic compound.